In this video, we're continuing with Chapter 11, and we're going to be looking specifically at similar polygons. So, our definition of similar polygons: two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. Now, the congruent part of this is pretty straightforward. The corresponding angles, the ones that match up, are going to be congruent. But this word proportional, that's a little bit more difficult. So when we say proportional, and I'm going to repeat this a lot so that we can hopefully remember that. When we say proportional, this means the ratios of the matching sides. Okay, these are the corresponding sides. So the ratios of the corresponding sides are equal. Okay, so that's what we mean when we say proportional. You want to think about the ratios, the fractions that we make out of the sides that match up being equal. Okay, so if I've got quadrilateral quad similar to quadrilateral light, okay, this means quadrilateral QUAD is similar to quadrilateral LITE. This squiggle symbol here means is similar to. So let's take a look at an example here. For example 1, we want to list all congruent angles and write a proportion that relates the corresponding sides. This is called the statement of proportionality. That's what we're going to put in this big box here. So let's start with the angles. We know that since these two quadrilaterals are similar, we know that because they give us this statement, that the matching angles, the corresponding angles, have to be congruent. So I've got 4 pair of matching angles. So I have angle Q congruent to angle L. Now, I can use the picture to help me figure out which ones are matching, but I can also use my similarity statement. So since the Q is in the first spot and the L is also in the first spot, those have to match. So a lot of times I'll just use this similarity statement to help me write my congruencies and my proportionalities. Alright, next we would have angle U congruent to angle I, and then angle A congruent to angle T. Okay, these match up over here, A and T, and then the last pair is D and E. So angle D is congruent to angle E. Alright, so again, you can use the picture. Sometimes it's easier to use the similarity statement here in case the drawing, the two figures are not in the same orientation. Alright, now for the sides we have to write the statement of proportionality. So again, I'm going to use this similarity statement here to help me, but you could also use the picture. So let's start with segment QU and segment LI. So QU is over here and LI is over here. Those are corresponding sides. So let's make a ratio out of those sides. So QU is to LI as, now let's do the next set. I have UA and IT. Again, we can see here's UA and here's IT. So UA to IT. So QU is to LI as UA is to IT as AD is to TE as DQ is to L. So this is our statement of proportionality. Statement of proportionality. Alright, so what I want you to do now is go ahead and pause the video and work out example B. You can make that correction there if you like. Example B. Now this one's a little bit different. Number one, we have triangles, and number two, one of the triangles is completely inside the other triangle. So in this first example, we could use single letters to name all our angles. Over here, there are some we can use a single letter, but there are others that we cannot. So go ahead and pause the video, see if you can write your congruency statements for the angles and your statement of proportionality, and then when you restart the video, you can check your solutions and make any corrections if necessary. So pause now. Alright, so here's what I've got for my congruent angles based on the triangles being similar and my statement of proportionality. So again, if you want to pause the video and compare yours to mine, and if you have any questions, make sure that you get some help. And then notice there's a couple angles here that I had to name with 3 letters because there's more than one angle at vertex R and there's more than one angle at vertex S, and if I just use one letter, there's going to be confusion. So that's a little review from first semester. As usual, get help when you need it, and we'll see you in the next video.